The first computer-aided design tools were little more than replications of the drawing board on a computer screen. Soon after their introduction, people realized that while creating their drawings on the computer was not necessarily faster than doing them by hand, editing them certainly was. Improved editing capacity made it possible to make more significant modifications to the design more frequently because of the reduced turnaround time in the change process. The practices that were created for the drawing board were developed because it was impossible to communicate three-dimensional data to people along the development process, but perhaps that wasn't true anymore. People started to ask why the computer couldn't develop the two-dimensional views required by manufacturing from a three-dimensional model. And some even questioned whether or not two-dimensional drawings were going to remain valuable in the future. Many predictions were made, and in most markets still remain unrealized, of a paperless design environment. These technologies changed the landscape of the engineering department. Where there were three tiers, drafters, designers, and engineers, there were now new options. Some companies merged the roles of drafter and designer, while others put more of the design process and detail in the hands of the engineers. Once development of 3D design systems began in earnest, the limitation became less about the vision of the people creating the software applications and more about the limitations of the computing power available at the time. In the mid-1980s, when CAD first began to expand in use, the basic system that would run AutoCAD was roughly the cost of a new car. A 40 megabyte hard drive was too large for the operating system to use in one partition, and 1 megabyte of RAM was exceptional. Of course, this was all just one side of the CAD CAM story. The people in manufacturing were some of the first to adopt 3D modeling. Developing 3D models from the 2D drawings given to them by engineering to assist in programming the computer numerical control machines that had existed for years but were difficult to program. With the additional CAM tools able to program their behavior, the increased power of CNC machines made it possible to add more axes for cutting more and more complex shapes. The improved precision and speed for actuators, as well as the advancements in cutter material, made precision less expensive. In some industries, the efficiency of high-speed machining started to make the use of castings less appealing. CAD and CAM tools were developed largely in parallel, but without direct integration because of the different needs of the users. Some companies would adopt design standards geared toward making the programming easier, but the limitations on design innovation proved too costly. The processes used to create components controlled how those components were designed. Castings and molded components have to include geometries such as draft in order to be extracted from the forms and molds that make them. Because this type of component uses permanent tooling, it's cost prohibitive to change the tooling very often. This curbs the willingness to explore new ideas on an existing design. Machined components have limitations on the depth of the feature based on the tooling restrictions or whether a tool can reach an area. All of this must be taken into account when designing the components that would need to be machined. The CAD and CAM tools began to develop closer and closer relationships, and now in tools like Fusion 360 are integrated into a single package. The flexibility for the designer and the engineer to work in the fashion that they need, and the machinist to program in the fashion that they need without interfering with one another is a fantastic breakthrough. The single connection improves the communication between the design and manufacturing sides, making it easier to design components that are more manufacturable. Then came additive manufacturing. Additive manufacturing is sweeping away concepts of design for manufacturing, or at the very least, rewriting the rule book. Suddenly, the manufacturing process itself frees up the options for design. Initially, these tools were called rapid prototyping, or the even more dismissive 3D printing. But the potential for disruptive change in manufacturing is only beginning to be recognized. Every day, more materials can be used in developing components with better material properties at the end of the process. Design technologies such as generative design are able to leverage the flexibility of additive manufacturing to define new shapes that would be impossible to create using traditional machining. When additive manufacturing and high-speed machining are combined, new forms that can't be cast can be created with less than finished surface precisions, then completed using high-speed machining. This gives the time savings of having a casting with the flexibility of machined components for responding to design changes because no stock has to be maintained. As powerful as the evolution of CAD and CAM's individual processes has been, it's their merging that is providing the most promise for the future. When the manufacturability of the design can be evaluated as the design is evolving, it converts a serial process to a parallel process. Removing data exchange decreases the risk of wrong parts being cut. Fusion 360 is a perfect example of how blurring their traditional roles, responsibilities, and technologies can open opportunities for people who are not professional engineers or machinists to explore creating their own ideas without the limitations the early tools placed on the process. It has taken a very long time for CAD and CAM to truly come together, and with the emergence of new technologies, new chapters in digital manufacturing will continue to be written well into the future.